Good morning, one and all. Today we are going to discuss about reconstructing software architecture in the unit 4 part 2. Okay, how to reconstructing software architecture. Okay, we are going to introduce that. We are using architecture reconstruction, in which the as-built architecture of an implemented system is obtained from an existing system. That is the meaning of what is meant by reconstruction of a particular architecture. Reconstruction. So already it will be exist. Okay, na? Then we are going to implement as built. We are going to implement or adding something or updating something for existing system. That is called reconstructing. So in this point, we using architecture reconstruction, in which the as built architecture of an implemented system, already it is implemented. Okay, as built architecture of an implemented system is obtained from an existing system. Okay, na? This is done through a detailed analysis of the system using tool support. Okay, now how we can reconstruct the system after analyzing that? After analysis is done by some analysts. Okay, na? So then with the help of some tools, it will be going to reconstruct. That is the reconstruction. The tools extract information about the system and aid in building and aggregating successive levels of abstraction. So what the use of these tools? Okay, apart from using this tool, what is the use? These tools are used to extract the information about the system. So it will be access. Extraction is nothing but what? Extract is nothing but accessing. Okay, na? We are getting something, we are mining something. That is the meaning of extract. Okay, na? The tools are used to extract information about the system and aided in building and aggregating successive levels of abstraction, and also they are summarizing or nothing but aggregating some successive levels of abstractions. Okay, na? That is the general meaning of reconstruction. Okay, na? If the tools are successful, the end result is an architectural representation that aids in reasoning about the system. Okay, na? So apart from this, when we are using these tools, when the tools are successful, so what is that? The end result of an architecture representation is aided the resourcing about the system. Okay, at the end, the result is reasoning about the particular system. In same cases, it may not be possible to generate a useful representation. This is sometimes the case with the legacy systems that have no coherent architectural design to recover. Sometimes it is not possible to recover some coherent related diagrams, although that in itself is useful to know. Sometimes, mostly it will be used, sometimes it not useful to recover the particular architectural design sometimes. Okay, na? Architecture reconstruction is an interpretive. Okay, na? Why we need to reconstruct the architecture? The architectural reconstruction is an interpretive or interactive and iterative process. It is not stop somewhere else. Okay, na? It is interpretive. Okay, it will be more interpretive and interactive. It is very interact with the to the particular users or clients and whatever it may be. Okay, na? While reconstructing the software architecture in the first level creation of a architecture, somewhere it will be missing. The lack of interaction will be missing, or some lack of interpretive will be missing. So while reconstructing these software architectures by using some set of tools, it will be successful. According to, we can say, the architectural reconstruction is interpretive or interactive much more than earlier, and it is iterative process. It's not stop somewhere else. Okay, it will again and again it will be going to update some of the features with the help of some existing current tools according to that advanced technology. So that's why we can say it is an interpretive and it is an interactive and it is a iterative process, okay, involving many activities. It is not automatic, it's not a default, it's not performing any default actions. It's that is the meaning, it's not automatic. It requires the skills and attention of both the reverse engineering expert and the architect. Okay, when we are going to reconstruct the architecture, it requires the skills and attention of the, it requires the skills from engineering experts, and also it will requires the attention from the architect. Okay, that is very important here. It requires the skills and attention of the both reverse engineering experts and the architect in someone who has substantial knowledge of the architecture, and also it will require some substantial knowledge of the particular architecture. That is the meaning of it requires the skills and attention of the particular reconstruction. And also it is a largely because it's a largely because architectural constructs are not represent explicitly in the source code. Okay, it's not represent explicitly in the source code. That is the main thing. Okay, because it's largely means its architectural constraints are not represented explicitly in the particular source code. So that is the reconstruction. Okay, by using some skills, it is a inbuilt architecture. Okay, already it is implemented. Okay, we need to obtain something from the existing one. We are reconstruct the software architecture. How we can reconstruct the software architecture? With the help of some tools, with help of some successive tools. Okay, that's why it will be interactive with more with the users, and it is interpretive and it is a iterative process. It's not stop somewhere else. It is not an automatic thing. Okay, it requires the skills as well as attention of the both reverse engineering experts as well as the architecture. It's largely because architectural constructs are not represented explicitly in the source code, and there is no programming language construct for layer or connector or other architectural elements that we can easily pick out of the source code file. Okay, we are not, there is no programming language construct for layers. Okay, we are not using any programming layer logic to construct the layers or connectors. Okay, or other architectural elements. Okay, architectural patterns, if used, means the styles if used, are seldom labeled. Instead, architectural constructors are realized by many diverse mechanisms in the implementation. Okay, it will use many drivers mechanism for implementation, and usually a collection of functions, classes, files, objects and so forth. Okay, it will be usually uses a collection of functions or classes or files or objects and so on. When a system is initially developed, its a high level design or architectural elements are mapped to implementation elements. So when the system is initially developed, it will be mainly focusing on its high level design, and also it will be mainly focusing on architectural elements, how they are mapped together and how to implement the elements. So therefore, when we reconstruct these elements again, we need to apply the inverses of the mappings. Okay, when we are going to, initially it will be done above the according to above point. So you want to reconstruct them again. So we want to reconstruct the elements again. We need to apply the inverses of the mappings. We can choose the mappings among the particular elements to get the high interpretive and high interactive and high it is why, because it is the looping, again it will be repetitive, that's why. Okay, and also coming up with those requires architectural insights. So familiarly with the compiler construction techniques and utilities such as grep, sed, evac, perl, python and excel, acc is also important. So which type of tools we are using to map or to inverses of these elements, we want to reconstruct these elements, so we are using some techniques. What are the techniques? For example, we want to construct a compiler construction compilers, so we are using some techniques and utilities. What are those? grep tools we are using, set tools we are using, evac tools we are using, perl, python and lexical analysis, lexical analyzers and acc is also important. This type of tools we are using to construct the compilers. So now we want to construct the compilers, we use some techniques and utilities. These are the examples for the particular tools to construct the particular compilers. This approach can also be used to recover as build the architecture. Okay, na? What is the main use of these type of approaches? Why are using these type of tools? Okay, na? Based on this approach, we can also be used to recover as built architectures. So what are the as built architectures we are having? What are the existing architectures we are having? Okay, na? We need to approach and we need to recover the particular as built architectures to check conformance against as designed architectures. Okay, now this assures us that our maintainers, okay, now, are also our developers for that matter, have followed the architectural edicts set forth for them and are not architecture breaking down abstractions, bridging layers, compromising information hiding and so forth. Okay, now that is the main thing, edicts. Okay, now the reconstruction can also be used as the basis for analyzing the architecture. So the reconstruction is mainly used to based on the analyzing the architectures. What are the bases we are using to analyzing the architectures? That is the main use of the reconstructing the software architectures, why we can reconstruct. And also the architecture reconstruction has been used in a variety of projects, okay, ranging from MRI scanners to public telephone switches and from helicopter guidance systems to classified NASA systems, it has been used. So where we are using this architecture reconstruction, we are using this architecture reconstruction in variety of projects, from MRI scanners, okay, na, in means hospitals, hospital management, and also to public telephone switches, okay, na, telecommunications, and also for example and from helicopter guidance systems, okay, na, so and also we are using NASA systems, it will be used. Okay, now based on these particular projects, we are using this particular architecture reconstruction. So why, what is the use? It documenting architecture for physics simulation systems. So according to that, we can documenting this particular redocumenting the architecture. So based on this, when we are reconstruct the architecture, automatically we can redocument the particular architecture. So that is natural. And second point, to understand architectural dependencies in embedded control software for mapping machinery. So we want to understand the particular dependencies in embedded control software for mapping machinery, to evaluate the conformance of a satellite ground systems implementation to its reference architecture, to understand different systems in the automotive industry. So based on these situations, we are using the architecture reconstruction in different areas or in different applications. And the workbench approach, here we can see the workbench approach of the architecture reconstruction. So what is workbench approach? Okay. In architecture reconstruction requires tool support, as we know from the previous, it requires a tool support, okay, but no single tool or tool set is always adequate to carry it out, okay. Now no, with the help of a single tool it's not possible to reconstruct the software architecture. So that's why, because we are using set of tools, always we want to educate the particular output. Carry it out means we finally what is output. They can reconstruct the architecture for better implementation, for better use. That is what result, that is an output, okay. A set of tools, some set of tools, they are always be adequate to carry out it. For one thing, tools tend to be language specific, and we may encounter any number of languages in the artifacts we examine, okay. Now these tools are based on the language specific. According to language they are specified, and encounter any number of languages it's required. We need to examine according to the particular reconstruction of a particular architecture. A nature MRI scanner, for example, can contain software written in 15 languages. For another thing, data extraction tools are imperfect. They often return incomplete results for false positives, and so we use selection of tools to argument to check each other. Finally, the tools of reconstruction vary discussed above. So sometimes when you are using some tools, MRI scanner for example contain software written in 15 languages, for example. Why they are written in 15 languages? In some situations when they are extracting the tools are imperfect. That's why we are also develop this reconstruction we want to get the positive results. So we are also using the other selected type of tools. And also what you wish to do with the recovered documentation will determine what information you need to extract, which in turn will suggest different tools, okay, based on our requirement, which type of document we required for recovering, okay. This type of suggestions will be written from the different tools. Taken together, these have led to a particular design philosophy for a tools set of support architecture reconstruction known as the workbench, okay. Now a workbench means what? Always it will be going to the check again and check to get the better results with the help of different tools to extract the useful information to recover the particular documentation according to reconstruction of a particular software architecture. In simply we want to say that is called workbench. Reconstruction is known as the taken together as have led to a particular design philosophy for a tool set of support architecture construction known as workbench, okay. Now a workbench should be open and provide a lightweight integration framework whereby tools added to the tool set do not affect the existing tools or data unnecessarily, okay. Now that is the another point of the use of workbench, okay. Now it should be open means what? Easy to integrate new tools as required, okay. Now that is the meaning of it should be open. So it will be, you want to integrate the tools according to the particular usage. It will be easy to integrate the tools and provide a lightweight integration framework. It also provide the better and lightweight integration framework. Already I said what is framework in the design part also. It's having an umbrella activities, how the task is going to work, what is first and what is the next. That frame is called as a that framing is called as a framework. It is an umbrella activities whereby tools added to the tool set. Okay, while they are adding some tools to the particular tool set, while adding those tool set do not affect the existing tools. It's not affect any existing tools or data unnecessarily. Okay, it's not miss its meaning of it. That is the main thing. And next one, reconstruction activities. Software architecture reconstruction comprises the following activities carried out iteratively. Okay, it is a iterative process kada reconstruction anedi. Okay, it will be comprises the some following activities. It's carried out iteratively. First one, information extraction. What is the first one? Information extraction. Already I said what is information extraction. We are getting something from, okay, that is the meaning of information extraction. We are getting useful information. Okay, that is the purpose of this activity is to extract information from various sources. Okay, now from the various sources we want to get the information. Okay, that is the main purpose of this particular activity, that is called information extraction. The purpose of this activity is to extract information from the various sources. Next one, database reconstruction. Database construction. Okay, database construction involves converting this information into a standard form such as the Regi standard form. Okay, that is the main. Whatever the information is extracted with the help of information extraction, then we are taking the another activity that is called database construction. Once the information is collected, we are going to construct the particular database. Okay, now that is the main thing. Database construction involves converting the information into a standard form. Okay, now we are going to convert the information into a standard form. For example, we have to consider an something. What is the logical structure of database? The logical structure of database is the tables. Okay, that is the form of standard form. That is a standard form to store the different types of information into a particular storage device. That is a source. Okay, now the database is a source. Okay, now here we are collecting different types of information. We want to create a employee database. We want to create a students information database. We want to maintain a staff information. So okay, different types of information we are going to maintain. Okay, now but it having different types of attributes. Okay, now those all information you can store in the form of a particular standard schema, that is the structure. Okay, and also we can saw data structures, for example. Okay, the data structure is also a storage device. Okay, now we are using different types of data structures. We want to structure the data, we want to store the data before going to stored in a particular memory. Okay, now we are using arrays, we are using link trees, we are using graphs, we are using linked list, we are using different types of structures. Okay, that is the thing. That is called database construction. Okay, whatever the information is available for us in front of us. Okay, we are going to arrange that information. We are going to represent that information in a particular structured form. That is called database construction. The tuples based data format in that form is a relationship entity. One is having the relationship from entity 2. okay na, means attributes. Okay, already I said that. Okay, the tables is not, the table is nothing but the logical structure of database is tables. What is the table? It's a rows and the combination of rows and columns. Okay na, each column maintains the what entities or attributes. Okay, each row cell maintains what value of the particular attribute. That is the main thing. And an SQL based database format form which the database is created. Okay na, how we can create store the data in a particular tabular format with the help of structured query language. Okay, we are inserting the data, we are updating the data, we are deleting the data, we can maintain different types of DDL, DCL and DML commands. With the help of these things we are construct the database. That is the meaning of that sentence. Okay na, and SQL based database format form which is the database is created. Okay na, that is the main thing. Next, view fusion. That is view fusion combines information in the database to produce a coherent view of the architecture. So we need to create some views. Okay, according I required some, I don't want required enter the database, I want to require some portion of the particular database, I want to select some view from the particular database or whatever it storage source. Okay, that's why we can focusing on the another type of activity that is called as view fusion. That is what view fusion combines information in the database to produce a coherent view of the architecture. That is the example for data warehouse ankochu. That is it combines the multiple values together. Okay, that is, and reconstruction based on that fusion we can reconstruct again. That is, the reconstruction activity is where the main work to build abstractions and various representations of the data to generate an architecture representation takes place. Okay, that is it's the reconstruction activity is mainly it works to build the abstractions levels, it mainly build the levels and various representations of the data to generate an architecture representation takes place. That is the main use of reconstruction. First, what we need to do, extract the information. So according to that information, so we need to construct the database with the help of for example SQL based database format forms like and also we can choose the view fusion, then we can reconstruct. That is the main thing. The reconstructor extracts the information from the system and either manually or within the use of tools abstracts the architecture from it. The architecture is obtained by the reconstructor through a set of hypotheses about the system. So who will do these all activities? The reconstructor. He is also an architect. Okay, the reconstructor extract the information from the system. Okay, where from he is extracted from the system only and either manually or with the use of some tools. How we will extract the particular information is manually. Manually is difficult, it is a small data, so based on it will be we can manually do it, but it's not possible to do always manually. Okay, we can store the large number of information, for example large volume of data we can store. It is difficult to extract the information manually. That's why they are using, in some situations they are using mostly tools, abstract the architecture from it. The architecture is obtained by the reconstructor, okay, through a set of hypotheses about the system. Okay, these hypotheses reflect the inverse mappings from the source artifacts to the design. Okay, that is mainly what is this use of this hypothesis, these main points. It will be reflects the inverse mappings, okay, to reconstruct the particular design or artifacts. Ideally the opposite of the design mapping sometimes. They are tested by generating the inverse mappings and applying them into the extracted information and validating the results. So then after doing that, what they can do, they can test it by generating the inverse mappings. Okay, na? They can test the results after reconstructing the different types of hypothesis by inverse the different types of mappings. Okay, na? They are test the results by generating the inverse mapping. After inverse mappings, which type of results will be generated, they will be tested and applying them. Okay, according to that they will be applying to the extracted information, and also they are applying the extracted information to the particular results, and again they will be tested, and also they are validating the results. Again they are validating the results. Okay, they can again they can cross check the results of first architecture results, and after reconstruction which type of results they are got. Okay, they are also, they can validating them, the correct output we are getting or not. That is the meaning of validating the results. Okay, now that is the main thing of main uses of this reconstruction of a particular architecture. Okay, this is the block diagram for reconstructing the architecture activity, architecture reconstruction activities. What are the activities we are discussed right now? Okay, according to this, how they are going to performing their activities or means actions. According to that, this figure represents that information to us. Here we can see view extraction. So means what? Information from where? From different types of sources. We want to get the information. What we require? Database. That is for example, according to our explanation, we require some data storage, that is database. So okay, now so what is the main thing? They are extracting the information from the database by using some tools, lexical analyzing tools or parsing tools or profiling tools, different types of tools they are using. Okay, now so why they are extracting these information? For database construction, again reconstruction. Okay, now so based on this reconstruction, so they are extracting the particular information. Okay, now so then they are reconstruct. Okay, pattern definition and recognition. So where they want to change, so which type of tools they are adding to the some set of tools to get the different types of outputs what they expected. So based on that they are going to reconstruct the particular architecture. So in this situation they are mainly choosing pattern definition and recognitions. Okay, now this mutually they are interfacing together, visualization and interaction. While performing this, they are interfacing together for visualization and interaction. So always when you are going to reconstruct, this person is always be interact with this particular database information. So then they are presentation of the particular document. Before going to do this all, what is the third one? View fusion. Okay, in which view they are going to reconstruct, that is the view fusion. Okay, now first they are collect the information. Based on the information they are construct the database construction. Based on that they are view some fusion. So based on the fusion, where they want to change, where they want to update it, where they want to add some tools to set of tools, based on that they are going to reconstruct the particular database. While they are reconstructing, they are performing these things, again they are presenting them. Okay, now what they are doing here? Okay, now what type of tools they are using, what type of skills they are using, what type of mappings they are using. So these all are going to be documented again here. This is called documentation. So according to first activity, view extraction, information we can collect. How we can collect this? By using this again they are going to construct the information. So how they are going to construct the information? By using some tools, lexical tools, parsing tools and profile tools and etc. So after construct the database, they can view some fusion, okay, where they want to change, where they want to update. So then they are adding something to this, again they are reconstruct. So what the changes made, what type of tools they are using, which tools they are adding to the set of tools without missing the data, without any faults, what type of mappings are done, so and what type of results they are getting, they are then they are validating the results from previous to current. So based on that they are preparing the documentation. That is also very important, okay. Now in this class we are discussed about very important concepts, why we are what is the use of reconstructing the software architecture. So we are discussed about introduction of reconstructing software architecture, and how we want to reconstruct that, which type of tools we are using, and also and what is the meaning of workbench. So what is the use of workbench also we know, and also we discussed about a very important concept that is called as reconstruction activities. We discussed about various types of iteratively carried out some following activities about information extraction, first one, and second one database construction, view fusion and reconstruction. Okay, this is the pictorial diagram, block diagram of the according to particular activities. In the next class we are going to discuss about individually what is information extraction, what is the use of it, how to perform it, and what is meant by database construction and all. I hope all you understood. Thank you one and all.